Hi everyone. There were some technical difficulties with the live lecture and I'm still working on getting access for you all. But in the meantime, what I'm going to do is just re-record the content of the lecture so that you have it so you can use it for studying. So there were a couple of main questions that people asked. One was about the measurement scales. So there were 4 different kinds of measurement scales that we talked about: nominal, ordinal, interval, and ratio. And basically these have to do with the type of data that you collect. So nominal data is data that categorizes things. So this might be by political party or eye color or gender, but these are just placing things in category. No one is better than the other. So when we have nominal data, when we've categorized things, we can look at the relative frequency. So how often or how many people or observations fall into those categories. So looking at the observations you did for last week, you might say 75% of the people observed were women, or people spent 90% of their time watching others. That's the kind of information you can get from nominal data. Next is ordinal. So ordinal is when you have people rank the orders of things, so which is your first choice, second choice, and third choice. What it doesn't tell you, though, is by how much is the first choice your first choice. So for example, if I asked you to rate the presidential candidates and you rated Trump, then Clinton, then Sanders, you've ranked them 1, 2, and 3. But maybe you like Trump a whole lot more than you like Clinton and Sanders. So Trump is really high up, Clinton and Sanders are lower down. I can't tell that by just having that ordinal data. Next is the interval data, and here all of your responses are on the same dimension. So the distance between the responses are the same, but there is no meaningful zero. So temperature is really the best example of interval data. So if you compare 10 versus 20 degrees, the difference between those two temperatures is the same as the difference between 80 and 90 degrees. It's still 10 degrees. It means the same thing. However, a temperature of 0 doesn't mean that there is no temperature. 0 is arbitrary on the scale of temperature. So we get a little bit more information with interval, but that 0 doesn't really mean anything. Finally, ratio is similar to interval, where all of our responses are on the same dimensions, distances are actually meaningful, but a temperature, there's a true 0, which means that 0 means the absence of something. So for example, a ratio scale might be the number of times a child engages in aggressive behavior, or how long it takes you to get to school. If your answer is 0, that means you live on campus because it takes you no time at all. If you live 30 minutes away, that's twice as long as someone who lives 15 minutes away. Okay. Moving on, there was also a few questions on quantitative versus qualitative data analysis. And this is kind of tied in with the levels of measurement we just talked about. Qualitative data analysis is more descriptive. Basically, you collect a bunch of narrative type data, like the first observations you did last week, and try to look at it as a whole to find patterns. But here, the patterns you're looking at and the things you're describing are verbal patterns. So for example, maybe you're observing interactions at a cashier, at a store, and maybe you notice that women seem to engage in more interaction than men when they're making a purchase, and it seems to be because they're uncomfortable with silence, whereas men don't really care. So the goal here is really to summarize the big patterns verbally. Overall, what did you see? Can you describe the quality of the interactions? In contrast, quantitative data analysis is about getting numbers. So here we're looking at we want to come up with specific statistics. Now, which statistics you can use depends on what level of measurement you've collected. So if you have nominal data, like the second part of your observations where you checked the boxes, you can look at relative frequency. So you can say 75% of the people you observed were sitting alone, 25% were engaged in interaction. If you have ordinal data, then you can do rank percentages. So you can say 45% of people ranked Trump as their top candidate, 40% ranked Clinton as their top candidate. If you have interval or ratio data, You can calculate means, so you can calculate an average score. And you can also calculate the standard deviation, which is the average distance from the means. So you might say an average cashier's transaction takes 3 minutes. And that would be ratio data because you're calculating the number of minutes that the transaction takes. If it takes 0 minutes, there is no transaction. If it takes 5 minutes, it's twice as long as if it takes 2.5. So the big distinction to know here, though, is that qualitative data is about summarizing in words. Quantitative data is about using numbers. Okay. Next, I had 2 questions about breaking down the types of observational research. The best answer I can give for this, I know I talked about in the recorded lecture as well, is this figure 4.1, which is from page 97, I believe, in the current edition of the textbook. So when you're trying to distinguish between the types of observations, the first thing you need to do is say, is it direct or is it indirect? If it's direct, you're observing the behavior while it's happening. If it's indirect, you're observing the behavior after the fact. Most of what we look at is direct. So if it is direct observation, then you need to decide, okay, is the observer intervening on what's happening in some way? If the observation, the observer is not intervening, then we call it naturalistic observation. So for example, the observations that you did were live, so they were direct, but you didn't intervene in any way. You just hopefully kind of stood back and observed what was going on. So that would be a naturalistic observation. If, however, you were at a restaurant and you were observing the waitress behavior, but you were one of her customers, then what you do might affect how she behaves. So you've intervened. So that would be participant observation because you're part of the intervention or interaction. And of course, there are other types of ways that experimenters might intervene as well. So that's really the best way to break down these different types of observational research. Next, there was a question on the types of sampling. And I assume this question was about the observational research chapter, although the types of sampling is relevant for lots of stuff. But there's tons of different types of sampling, but the goal of all sampling is to improve external validity. So how much can your results be generalized outside of what you immediately observed? And of course, that's the goal for any experiment, is to be able to say, this is what we looked at in this specific study, but we think it's true for everyone. So the first type of sampling is time sampling, where you look at participants at different times during the day. So for example, if I want to know, do cars stop at a crosswalk to let people cross? That might differ if I'm watching them at rush hour versus if I'm watching them at the middle of the night, in the middle of the night. So I would need to watch at different times to establish what's going on. Next is situation sampling. So here we're looking to see if the same behavior happens in multiple situations. So for example, if you think about the question on your last test, we're looking at teaching styles. I might say, do teachers use lectures more in math classes, but discussion more in science classes? So I need to look at different situations, in this case, different samples different subjects to see whether that same style is being used. Likewise, I might say something like, do kids who are alone at recess also play alone when they're at home? Same behavior, different situation. Finally, subject sampling. This one's kind of obvious, and we'll talk more about this actually when we talk about survey research. But you don't just want to watch one person. You want to make sure that you get a sample of participants who represent the population that you want to generalize to. So if you're watching kids at recess, you're not just going to watch one kid for the entire time. You want to get a bunch of different subjects or participants to make sure that behavior is true overall. Okay. The final question was about correlational research. And for correlational research right now, all you need to do is be able to interpret the correlation coefficient. You don't have to know how to calculate it. I think that that's what the person was referring to in this question about determining the percentage or ratio. Right now, all I want you to do is be able to interpret it. So there's a couple of basics you should know. One is that a correlation coefficient will always be between -1 and +1. A coefficient of 0 means that there's no relationship. So maybe the correlation between something like shoe size and GPA. Probably the size of your feet has nothing to do with your GPA. So that would be a correlation of 0. A negative correlation means that as one variable increases, the other one decreases. So for example, in a face-to-face class, there's a negative correlation between test score and number of absences. The higher your absences, the lower your test scores. A large negative correlation would be a number closer to closer to -1, means that there's a strong relationship and almost no exceptions. In social sciences, we very rarely get perfect correlations, like -1. So anything above a 0.7 or a -0.7 would be considered a large correlation. A small negative correlation, which is closer to 0, means that this might be true some of the time, but not always. So maybe there's a correlation of -0.2 between alcohol consumption and GPA. In general, the more alcohol consumed, the lower the GPA. But some students consume a lot of alcohol and do very well, and others have a low GPA and don't drink. So it's not perfect, there are a lot of exceptions, and that's really what a small correlation tells us. Likewise, a positive correlation means that as one variable increases, so does the other. So your grade on assignments will be positively correlated with your grade in the course. Again, a large positive correlation, close to 1, means that there are few exceptions, and a small positive correlation, closer to 0, means that this is generally true, but there might be exceptions. So for right now, what you need to understand when you look at correlations is if I told you, for example, there was a correlation of 0.63 between heat and crime, I'd need you to be able to tell me what does that mean. We know it's positive, so what this suggests is as temperature increases, so does the crime rate, and it appears to be a relatively large correlation because it's 0.63, it's relatively close to 1. If, in contrast, there's a correlation of -0.15 between Facebook use and self-esteem, we can look at that correlation and say, okay, well, it's negative, but it's relatively small. So it seems like sometimes more Facebook use leads to lower self-esteem, but it's not a particularly strong relationship. So that is really all you need to get out of this. I think I answered all of the questions that were posted. I hope you find this helpful. We may try this again later, and hopefully we can get the live lecture working. Thanks, and have a great week.